And then, as it says up there, I'm Mike Lovell. I know a little bit about SSH. And so that's what we're going to, or a part of it is what we'll be talking about tonight with SSH certificates and a tool that I've been working on for managing them and potentially making them a very useful and easy to use feature, but yet to be seen whether or not that actually actually reaches my dream. Who knows? Anyways, there's contact info, location to get the slides, etc. This is actually a repeat of a session I did at OpenWest a couple months ago. So if you were there for that, I'm sorry. Or I don't think the video for it has gotten online yet.
I don't know where the video
Have they not gotten any of OpenWest up yet?
No.
I did a query OpenWest 2017 and couldn't find anything. I
There's-
looked for my
Oh, that's sad.
As far as I don't even know where the video is. So I know we got video.
Yeah, I know it got recorded, but...
I don't know.
Well, either way, Dory's pretty good about this stuff, so I'm guessing it will be up pretty short, or short up after... Huh?
Oh, about this?
This one. Yeah, so this will be up shortly, and so
It'll be dope.
internet, now you get to finally see it. Anyways, how many of you used SSH Keys before? Okay, just about everyone. I'd be a little surprised if you hadn't. Just a little quick review of things that are commonly done here. You generate a key, you copy it to the host, and then you can SSH to the host using that key, and you don't have to put in your password every time. Often touted as a more secure way of doing SSH. The one important thing that you probably should be, I guess, how many of you keep the private key of your SSH key pair unencrypted on disk? Good. That's not what I was expecting. How many of you, if you keep it encrypted on disk, I'm guessing then that you all have used SSH-agent before. Is that right? Okay. So just quick review there. You run the agent. If you have an environment variable set, you can add a key to the agent, and then you can SSH. That -A is optional, but if you want to forward your agent so you can use your key across multiple hops, you do the -A or put it in your config file. And hopefully you're aware of the security risks associated with that. So, SSH keys are great. They've been with us for a long time. Make life easy, but there are some headaches with them. When you're talking about lots of users in a system, distributing lots of keys for individuals can be difficult. Granted, modern tools have made it so it's a little easier to deal with this aspect, but it's still something that you have to worry about.
What tools?
I mean, configuration management systems, Puppet, Ansible, Chef, Salt are probably the four biggest that you could use, or commonly used config management systems, at least the most talked about. And you can, they almost all have modules for putting a public key into a user's authorized keys file. There are other things that you can do. One thing that's been somewhat common, and
Also the known host file.
they can also manage known host file. Yes. Another thing that's commonly done. How many of you used FreeIPA before? Okay, a few of you. So it actually has mechanisms for storing the public key for user inside of the LDAP directory that's part of FreeIPA, and has mechanisms for then querying that key out of the directory. So that makes it a little easier. You don't have to worry about distributing it yourself. But on the other hand, that requires network access for the host to be able to look up your public key. Other things, how many of you have actually verified a host key before SSHing to a box? Crickets. Yeah. I mean, we all see the little prompt. I haven't seen this host before. Do you want to trust it? Yes. So that's I mean, trust on first use has potential issues. Luckily, after that, it's pretty secure. You can get around or potentially work with that with SSH Key Scan or SSHFP records. SSHFP, though, you probably don't want to do unless you're doing DNSSEC environment. By the way, SSHFP records are DNS records meant to store the public key for a host. So the SSH client, when connecting, can potentially do a DNS query to find out what the public key of the host is. But if you want to do that, you probably should do a DNSSEC setup so that someone can't man in the middle of your DNS requests and feed you lies. And then you've also got the problem of you've got to get the host keys into the DNS or into DNS in advance. So headaches there. Compromise of a key requires someone to verify that it actually gets removed from every host. And keys themselves don't include any constraints. So, but there are a number of things that you might potentially want to constrain users on. Like, for example, at my place of employment, for our administrative users, on some systems where we have people we don't trust, in the user's authorized keys file, we add no agent forwarding to their public key, so that even if they accidentally request the agent to be forwarded through an untrusted host, the SSH server won't do it. And so if someone compromises that host, they can't then impersonate the admin. But keys themselves don't contain those constraints. And if the user could edit their authorized keys file, they could potentially change some of those. And maybe you don't trust the users to change them. And so there are ways, why did that not go forward? There we go. There are ways that we could solve this with configuration management. Like, for example, with this little bit of Puppet code, Puppet will make sure that that public key is in my user's authorized keys file. This is a way you would do it in Ansible. Don't really want to go into that. And there's been a number of different ways that these issues have tried to be solved partially, but not really completely. And there's actually been a number of really interesting articles that people have posted over the last, these are less, all three of these I think have gotten a bit of news this year. Wikimedia had an interesting blog post about how they handle this, because they have users coming into systems that they only trust for periods of time, etc. And so their answer was, we're going to have someone connect to a jump host. We'll start an SSH agent for that user on the jump host, and then add our trusted private key to that agent, and then let the user use that agent. So the user doesn't necessarily directly have access to the private key unless they were to somehow dump the memory of the agent, which hopefully they don't have permissions on the system to do. And so that lets them configure some static keys throughout their environment, give the users the ability to use those keys without giving the users direct access to the keys. So it was an interesting idea. This next one, SSH Secret, is a thing that will do, it basically works with config options and whatnot to basically use a new SSH agent for each domain that you're SSHing into. So like if you have multiple hosts under one domain, it'll use that agent for those hosts, and then for a different domain, it will use a different agent. That way, if something gets compromised, they can't potentially use all of your keys. Kryptonite was another rather intriguing one. This one is probably the most far-fetched one in my opinion. It actually keeps your private key on your phone, and then has infrastructure to have the SSH client somehow connect through something and do the negotiation back to your phone, which then does the authentication with the server. was an intriguing idea, but on the other hand, I don't particularly trust these things all that much. What if this gets lost? So I didn't particularly think it was that interesting.
Back it up to Google. You're fine.
Yeah, just back it up to Google. Git commit, git push, GitHub. There you go. That works too. So this is something that I've been thinking about for a while because it's a problem that we have at work to some extent. I mean, we have our own tools built to handle these things, but they're not the most elegant. And the big thing that I wanted to be able to get was, or I guess my requirements was I wanted something where I don't have changing config, something that's per user, and in these days, it's really you need to be able to rotate your secrets quickly. And all three of these can be handled with a feature that's actually been in OpenSSH for several releases. I think it first landed in 2011, maybe 2012, and that's certificates. And this idea borrows from SSL certificates, but I should caveat, these are not SSL certificates. They don't use an X509 format. They're not used for the initial, well, they are used for some of the authentication, but they're not used to necessarily encrypt the session initially. Though I could be wrong on that. But you can't, I mean, there's not like public CAs that you're going to go to and get a certificate, an SSH certificate from. So let's talk about a little bit about what is potentially in these. So the first thing we're doing is we're going to gather some bits of information. Most importantly, we're going to grab the public key of a user or a host and that user or host's name. In the documentation, or actually the specification for this stuff, it's called the principal. We'll gather up a few other things, and then we're going to take all those bits of information and we're going to sign them with a SSH key pair, with the private key and a key pair. That means then that the contents of that can be verified, that it hasn't changed, and that it is actually signed by the CA in the future. So in that case, all we need to do then is distribute our CA key. And you can actually use different CA keys for different purposes. You can have multiple. So you could have one CA that is used to sign certificates for hosts, another that's used to sign certificates for users, etc. Or multiple CAs for different users. And then your users and your hosts can validate each other using these certificates. Using information they already have, they don't have to talk to a third party. This is the basic layout of the information that's going to be in the certificate. And if you go look at the spec in the OpenSSH source code, they're also in this order. The public key varies based on what key type you're using, but we have all these bits of information. Start time, end time to specify how long a certificate is valid for. Critical options and extensions are basically the same thing, but these allow us to specify restrictions on what this key can potentially be used for. And there's a serial number so that it can be uniquely identified in the future. What type it is whether or not this is being used for a host or being used for a user. And the nonce at the beginning is just random bits of data that's used to help protect the signature and prevent against brute forcing things or whatnot. So we take all that. At the bottom, the CA will add its own public key, and then it will create a signature of everything up until that signature field. So it's the signature includes the key, the public key of the CA. And so using that, that could actually be cryptographically verified with itself. You don't need any additional data to be able to verify that it's a valid bit of information. When distributing the CA key, all of the system is doing then is verifying that the key that was used to sign it matches a trusted CA. So, what does it look like to do something like this? Well, the first thing you need to do is you need to create a CA key. And this is just another SSH key pair. So you're going to create that the same way you would any other key pair. You need to add that key pair for being trusted for a user or a host. You can add it to known hosts or authorized keys for a user, or you can actually add them as globals so that everything on the system uses them. I forgot to fix the typo in here. On both the two signing operations here, there's a -I option that's required. That is the name or the identifier of the certificate. You are required to add that. So I left that off on accident and realized that and didn't fix it before tonight. So oops. But when you want to create a certificate, you'll use SSH Keygen again. You give it the -S option, which is the path to the private key of your CA key. You specify, or on the case of a host certificate, you give it that -H to say this is for a host certificate. The -N is going to be your principal, and you can have more than one of these. So you could say that this, for example, on a host certificate, that it's valid for, app1, app1.example.com, and maybe an IP address. You probably don't want to put an IP address in there, but there's nothing stopping you from doing it. So you could list multiple things in there, or if you have like multiple layers of subdomains and you have shortcuts with DNS or whatever, you could add all of those in there so that your users can validate depending on which form of the DNS name they use. In the case of a username or a user certificate, you'll add their username. You could actually add multiple usernames to it. One moment. And then the last argument is just going to be the path to the public key that you're wanting to sign. And we had a question.
I was just going to say, is it wildcards?
So the question was about wildcards. I honestly don't know. I've never tried using a wildcard in there. So I don't know whether or not those are allowed. Something to experiment with later. All right, so some demo time. All right, so let me get my other thing here. All right, so I have, let's see, when is it going to? Let me actually edit something real quick. No, I need known hosts. Let me get rid of something in here. Okay, so I have a box that I can SSH to. Not trusted at the moment. Let's see. I'm going to go ahead. Yeah, let's go ahead and log into this guy. But first, let me come to another terminal here, and let's just generate a SSH certificate authority key. So keygen-f, let's call it CA1. And we'll still do RSA, but we'll give it a big bit number, because why not? So it's generating that. I'm going to be really bad here. Sorry. So we have that. The next thing let's do is we're going to sign our host our host's public key with the CA. So let me come back over to app1 here, and I'm going to cat out host rsa key.pub. Oh shoot, let me adjust this a little bit. Okay. And so I'm going to just, you can't see me selecting the text here, but I'm just selecting the contents of the key down here. And I'll come back over here and app01.pub. Pretend it's not already there. Oh crap, I need to remove some extra text that is getting added. Okay, so there we have our public key. Now we're going to sign that, gen-s. So we're going to give it our CA1 private key. We're going to specify this as a host certificate, app01 RSA host cert as our name. Actually, wait, we want this as our identifier. Our name is going to be, let's do app01 and app01.b256.net. And then our path to our public key. So you can see here it says that it signed a host key for this public key. And one thing we can do with SSH Keygen as well is there's the -l option, which will list out the contents of a certificate file. So we'll give it the path to that, cert.pub. And you can see here, it went ahead and it created a certificate for us with these bits of information. Here's the public key of the our server, the public key of the CA used to sign it. Here's the identifier that I specified on the command line. It defaulted to serial number 0. If you don't specify one, it's just going to fill that in with nothing. I didn't specify a beginning or end time, and so this is valid forever. So you would want to treat this just like you would any other SSH key, because it can potentially be used forever. In fact, if you had one of these compromised and had an unlimited lifetime on them, you'd probably actually want to go through and redo your CA infrastructure, because that compromise is valid forever. So don't do that. You can see what principles there are here and none of the other options. So let me now get the contents of actually, let me just SCP these. App01 cert.pub tab 01. Okay, let's come back over here to my terminal on app01. And I'm going to, let's see, actually, I'll just cp temp this to /ssh RSA, let's see, host RSA cert.pub. All right, so we have that in there, and let me copy this real quick. Now, the last thing we need to do on this is we actually need to tell the SSH daemon to use this certificate when clients connect. And so we'll just edit our sshd config real quick. You can see I actually already have this in here, host certificate. And let me just repaste this just in case I typed it wrong or differently this time, which it looks like I did. So we'll just then save and exit and restart sshd. Okay, so now let me come back to my terminal here, and I'm going to remove app01 from my known host file. And if I SSH to app01 right now, I get asked. But let's do this. Let's cat our ca1.pub file. I'm going to write it into my known host file. And then I'm going to edit it real quick because I do need to make one change to the line that it just added. I need to add cert authority to the beginning, and then I need to tell it what domains or host names I might use this for. Here's one case where you can't use a wildcard. You can just put star there, and it says use this certificate authority for anything, for connecting to any host to validate. So let's go ahead and save and exit now. And now, in theory, oh, fail. It's still asked. Actually, let me check. Let me try one thing. Nope. There we go. So I forgot the @ you can see it didn't prompt me this time for whether or not I want to trust that host key. Even though I don't have it stored in my known hosts, it's able to validate it using the certificate authority's public key. But I still got to type my password here. That's not all that fun. So let's get my own public key signed. So let's actually just go ahead and create one for me real quick. Mike key 1. Yes. Pay no attention to the pre-existing conditions. So there, I've generated a new key for myself. I need to get that signed by the certificate authority. So we'll do SSH Keygen -s temp CA1. We're going to specify the -cap I for the identifier, and we'll just say this is Mike's let's see, RSA key. Our list of principals. I'm going to just add my own username to this. And I'm going to actually say a validity. There are a number of different ways you can specify the time format for this. This is just saying it's valid until 1 week from now. And then I give it, let's see, key1.pub. So there it's generated a user key or user certificate for me now. And I can do, or I can inspect that now. And it looks somewhat similar, but there are a few important differences on this certificate compared to the rest. We've got some extensions here, and these are what allow me to do a lot of the normal SSH activities. You can see it is valid from now until a week from now, the 19th through the 26th. Again, serial 0. But with that validity, if this key gets compromised, it can only potentially be used until that period is over, or until that time has passed.
I have a question.
Yes.
So if I'm an administrator, and let's say I have a user that needs temporary access, so I'm going to do the 1 week. Could they just email you their public key, you sign it, and then give it back to cert, and they can use that?
So to repeat for the audio, the question is say you're an administrator, you have a user that you need to temporarily grant access to. Could they email you the public key, you generate the certificate, email it back to them, and then they can use it for that period of time? And the answer is a definitive yes. We had a situation where we were, or at a job I had where we wanted to provide temporary access to systems, and we came up with a kludge, but this totally would have served that purpose for us. We could have just given them a certificate that was valid, say, for that day, and they could get into the systems for that period of time, but then once that's expired, they can no longer use it. And with, in that situation, nothing that is being sent across the internet is private information. It's always the public keys. And so the risk of that being compromised isn't that great, or of that leading to a compromise isn't that great. So yes, it's a very valid use case. So I have now a certificate that is signed by the CA, but my server doesn't trust the CA yet. So let's get the server to do that. I'm actually just going to come back over here to app 1, and so we're going to copy, oh, actually, I need to get a copy of the CA public key. So let me just cat out this, and I'm just going to paste this into a file on the other side. So I'm back on my app server. I'm going to edit a file. Again, ignore pre-existing conditions. I'm just going to create a file that just has this public key in it. I could list multiple public keys in here, in which case those multiple keys would be used as different certificate authorities. And I need to make an edit to my SHD config again. Apparently my Control-R is not working. And I'm just going to go down here to the end because I already have this in here. So you would add an option into your SSH server, or you could add it to your SSH server that's trusted user CA keys. And that will tell the SSH daemon this is a CA to use for any user connecting. You could also put it in each individual user's authorized keys file. But we want this to work for multiple things, so we'll put it here. Let me just double check that that's the right path name, SSH user ca.pub. Oh, no, I used a different one this time, so we will edit this again. We'll give it the right path. And where's our nope. We'll restart SSHD again. So now, if I come over here to my terminal, I should now be able to SSH to app01 using my public key. It's going to determine the path name for the certificate and use it automatically. There I am. Got in without having to distribute my public key, and I was able to validate the host without previously having the host public key.
So in the scenario mentioned a minute ago, is there even any reason to send the signed key back if they're still using just their private?
So the question is, why does the certificate need to be sent back? The reason being, and it's kind of hidden here, is that when I did this SSH-I and gave it the private key, the SSH client appended -cert.pub to the file name to read the certificate. And I think.
So if it's there, it will additionally send the certificate.
Yeah. So the client does have to have the certificate so that it can present it to the server.
Got it.
And this is probably going to be too hard to actually pick out from here.
So for your agent, it's not like you're really loading a new key into the agent. It's just looking for that specially named file or whatever else.
Yeah. So you can see right. Let's see. You kind of have the cursor here. So with the SSH client, it read my identity file from here, which is the private key, and it then read the certificate. So it used both of those, and both are required on the client side for it to actually work.
Got it, thanks.
All right, so that's certificates in general. Let me come back to my slides now. And that was our demo. So this isn't perfect. You do have your public key that you have to distribute everywhere. This is a big one. The creation of a certificate requires access to the certificate authority's private key. And SSH Keygen itself, it's not going to be enforcing any policy for you. So if you're an admin and you're typing out the command to assign someone's certificate and you typo their principal or their username, or you forget to add a validity time or something else, forget to add options that are necessary for compliance reasons or whatever, SSH Keygen is still going to work for you. It's still going to do its job and give you the certificate, but you've got something that isn't right for your environment. And so some of these things are why I started a project that I've so far called Janus. Not set on the name particularly, but it's a working name so far, and it may end up sticking. And this is a Python utility and web app that can be used to provide access to a certificate authority. It is written in Python with only a few set of dependencies, mainly Paramiko, ECDSA, and wow, I have an extra comma in there, and the cryptography modules. If you want to use it in the server mode with the REST API, you need Falcon, Passlib, and Eventlet. And then for the client side, requests and pretty table. It's a tool that's meant to administer certificate authorities, as in multiple of them. You can have different authorities in there, each with their own policies associated with it, and you can give users access to those authorities as well. Different users access to different authorities. With that, each one, you can specify a list of policy filters, is what I've called them so far. That might not be the best name, that you can use to enforce requirements on the certificates themselves. It also is going to be doing things like making sure that the serial numbers are incrementing and are unique, and whatnot. Then there is also a basic HTTP API, somewhat REST-like. There is actually a mode you can use it in where it works entirely locally, but if you're using it in that mode, there's the risk of a user potentially getting access to the private key and doing their own certificate. So you probably don't want to use it that way, but you can. That's actually the mode I wrote first. The REST API came later. There's a couple utilities when you install it. Janus CLI is meant for the local form of it and also for running the web server part. That should be CAs, not CAS. So anyways, it can provide information about the different CAs, etc. Then there's just the Janus command, which is a REST client, command line REST client to the Janus server. It's not required. The API is just JSON with basic auth and whatnot so far, so you could make requests from any language that you choose. It uses a simple INI style configuration. You should really, I guess there's not much point in it unless you have at least one authority configured. And each authority needs a data store, a key backend, and a list of policy filters. So the data store is where it's going to store some information about the certificate authority. Mainly it's keeping copies of requests, copies of completed certificates, and what the current serial number is. Right now the only data store there is just a simple directory on the file system that it keeps data in. I do ultimately intend to add a database, but haven't gotten that far yet. The key backend defines how Janus accesses the certificate authority's private key. There are two of them right now. One of them is just straight reading an unencrypted private key from disk. You probably don't want to use that. The other one is it can actually use an SSH agent itself. And so it will talk to the agent to get the agent to sign things and then return that data. And then your list of policy filters, which define what restrictions you want on your certificates. All right, now let's go to a demo of it. So let me really quickly review my notes here. Okay, I covered all that. So I have running over here, oh, hello, I didn't close that. There we go, now we're back to the terminal. Need this one. So down here I have a current copy of the server running. It does have SSL support. I think it actually does require running on an SSL connection. I think I made that change. Can't entirely remember, something. But let's come over here now to a clean terminal and let's take a look at the config file for it. So I've got, let's see, is this the top? Nope. So up here at the top, in a global section, I have defined two different certificate authorities. One that I generically called users and one that I called break glass, which was, pun on the fire alarms in case of fire, break glass. So it's in something, with how it's configured here, you could use it as this is an emergency key that can get certificates signed that give users special permissions or something like that. So Here is the user's CA defined. I have 3 filters allocated or defined for it, and they're just processed in order. So I define a max duration on the certificate, so the certificate can only be valid for 12 hours. That's just the name right here, but down here I defined that filter, which Python class is used for the filter, and then the duration is 12 hours there. The ensure username filter makes sure that the username of the requester gets added into the list of principals for the certificate. And allow root lets you specify a list of users that are allowed to request root as the principal for the certificate. So here we're using the agent backend, which I've already started one and have it running in the background. This is the public key, and this is the path to the SSH agent it's using. The data store is just the directory data store, and we're just storing everything in varlib Janus. So there's that. Here's what I have for the break glass one, and actually here on this one I'm saying that it's only good for 12 hours, but I'm actually going to use a different filter that forces the username to be root. And so that's why I call it a break glass. In this situation, your users can request a certificate specifically for root. So say you have an LDAP directory storing all your users. If for some reason that's having problems in the middle of an emergency, users can just request certificates as root and then get in as root, and they can bypass your directory. And hence why I call it a break glass, because you would really only want to use that if things are really bad. And then for the API down here, I specify a path to an htpasswd file that contains the list of users. So that's that. So let's take a look here. So we'll just use the Janus tool. Let's see. Let me find. Okay, so you do have to specify a URL right now. I don't have a config file for the command line client to automatically detect that. So I'm specifying that the server is at this URL. And you can see there are 2 certificate authorities, and they have a status with them. So with the one that's offline, users can request all the certificates they want. It's not going to actually sign anything because the certificate authority is not available. The private key is not online to actually do any signing. Whereas the user's one, it is online. Janus sees that it has access to that key and can use it. So real quick here, let me go ahead and show. You know what? I think I forgot to. So I'm going to forward an agent here. So you can see I have no identities currently in my agent. Let me come up here. So I'm going to do no, not that command. So I'm going to do another Janus command. Here I'm going to do a certificate request. I'm going to do the gen key option. So I'm not providing the command line client a path to an existing private key. It's going to generate one on the fly for me. I'm specifying which CA I want to use, which is users. And actually here, let me do this. This way it's a little easier for the people in the back to see. Specify which CA I want to request the certificate for, and I'm going to ask it to also write the key that it's generating into this file. So if I run that, it's going to prompt me for a password, which is the credentials I would use to authenticate to the Janus server. And you can see it actually spit out a whole bunch of stuff because I still have it in debug mode. But it requested a new certificate with and it got an ID that you see there, a UUID. This is actually the ASCII contents of the certificate, and it's quite large because I'm pretty sure I used 4096-bit keys for everything there. And you can see it wrote the certificate. Let's see, actually. Let's see. There we go. You can see I have the key and the certificate now. The other thing too is you can see it detected that I had an agent running, and it went ahead and added that key to my agent. So now if I do an SSH add-l, you can see I've got the additional agent there. And so I could then use that for authentication purposes in the future. I don't have a tool from the remote client right now to grab the public key of a certificate authority, which is something that needs to get added. And so there's not an easy way for me to, in the few minutes we have left, for me to go add this the CA key to the app server and then log in using that agent. But, let me do this real quick. So you can see that it enforced policy on this. So I didn't specify a time frame on my certificate request. But you can see on this valid from, it's from 1955 to 7:55, so it's only good for 12 hours. So it went ahead and it did that for me. And you can see, I didn't say what usernames I wanted, but the policy said that this user, or my user, is allowed to get root, and so it went ahead and added root on there. And so I could SSH as root. It also used a unique serial number. Next time that something gets requested, it will get 12, etc. And so yeah, that's a highlight of Janus so far. Come back to the slides here.
I have a question. So if you're using it for just 12-hour certificates, you're basically every time you log in, you're going and getting a certificate, and that's what you use for your session until.
Yeah. So the question is, if they're only good for 12 hours, when you log into your system at the beginning of the day or whatnot, that you request a new certificate and you use that during the day. And yes, that is the intention behind this. That helps mitigate the risk of a compromise of a key being able to be used for a long time. Now, that is also only on the authentication of an SSH session. If you leave your sessions authenticated for long periods of time, like if you say you have a workstation at work that you use to access systems and you just lock the screen at the end of the day and come back and have your same SSH session still open, those sessions are still going to be open. It's just you can't use that key for a new session in the future. Another thing that I wanted to point out, when it added the key to my agent, it also detected the duration and it told the agent delete this key after so long, and so my agent will delete that after 12 hours automatically. So there's a question in the back.
Yeah, if I understand correctly, does it only mitigate the issue if the server is only allowing for certificate authentication there?
So are you saying in the case of a key compromise,
Yeah.
it's only protecting if it only allows certificate authentication?
Yeah,
Not necessarily.
So if a user goes rogue, because they're using both, right? They're using the key and the certificate from my earlier question.
So
If they log into a machine and then just add their public key to their known host or authorized keys file or whatever, you're still kind of up the metaphorical creek, right?
Yeah, so for the audio, the comment is that if a user goes ahead and adds their own unauthorized public key to their known host file, they could, and their access was revoked in the future, they could still use the persistent key to get in. You might be able to configure SSHD in a way that won't allow them. Actually, no, if you turn off public key authentication, it's going to turn off the certificate authentication. I don't think it supports one or the other. I think it's either both or none. I could be wrong on that. That's not something I've tried, not a use case that I'm trying to solve with this, because that's, in my opinion, that's more of an audit function than necessarily an authentication function.
Yeah, I mean, if the key's compromised, though, you can't solely just depend on, hey, I issued it.
No, I mean, if you
public signing and said it's only valid for 12 hours, so I can forget about it.
So that's true to some extent. If a key is compromised, you can't just assume that after 12 hours you won't be compromised. There is another thing with certificates, though, that I haven't covered, which it does have a revocation list support. So you could actually revoke that certificate. You do have to distribute the revocation list to the hosts, but if you do that, they immediately stop trusting the cert, even if it still has a valid time frame.
Yeah, but if you're trying to syndicate without the cert because somebody's just added the public key into
Yeah, I mean, this is not going to solve that problem.
Yeah, okay. I just
But
wanted to make sure I understood.
that's a problem that exists anyways. You could have a user that does that. Unless you have a way of validating that they haven't, you never know that they would have. And I'm not trying to solve that problem.
Yeah.
So that's not what Janus is meant to do, and so it doesn't alleviate that responsibility from you.
Sure. Yeah.
That is
I just
something
wanted to
that-
understand. Thanks for clearing up.
That can be solved by configuration management tools.
It can be solved by configuration management tools or just other audit
people's-
tools. Yeah.
Authorized
Yeah,
key files.
you could just, in your configuration management, say every user's authorized key file is empty, or that it's absent.
Right.
And configuration management will then take care of that for you.
So I was wondering if if this is intended to be used for temporary keys, like you had it set up there with the 12-hour keys, would it make sense to automatically, like you just had it in the temp directory, which isn't very secure because other people, would it make
Yeah,
sense to
temp
do
is world
something-
readable.
Right. Would it make sense to do something similar to what SSH-agent does with creating, just have your code just automatically create a directory for it, put the key in there?
So I could. My intention is actually that in most situations, the key actually never gets written to disk. Because you saw it add it to the agent, if you can leave off the key file and it's not going to write it.
Okay.
In which case, the private key never leaves RAM.
Okay. That's
So-
better.
Yeah, and my intention is, they should be short-lived. This is basically a re-implementation of Kerberos if you've used it, but it's the same basic ideas, and my intention is a similar style thing. There are other situations that I could also see it being very useful, like for example, if you're an administrator and you have outside vendors that you need to allow access into your environment on a temporary basis for like support contracts so that they can support your systems. This might be a useful tool. You can just create one account and then you just issue a short-lived certificate for them. You could be a company that's providing support to other customers, and you could pre-bake a CA public key into your appliance or whatever, or in the process, ask your clients to create a CA that sits in the appliance, or have a per appliance CA, and then get a certificate issued so that your company's support agents can then get into the systems to administer them. So there's a number of different ways where this is potentially useful. There is still quite a bit of work that needs to be done for it to really be a useful everyday tool that's also secure. Documentation definitely needs a whole lot of work. There's a lot to the API that needs to be done. I don't have host key signing in it all right now. My intention is to also get it so you can have a command line client that an administrator could run the tool, and it will get all of the host public keys off of a host, get them all signed by the CA, and put them into a file and reconfigure SSHD so that it uses those. That way you can get around this trust on first use issue. And there are ways that you can even do that potentially where you don't even need it done or with like a pre-authorized password or something. Ways you can get around the security and have it happen automatically. More filters. I mean, that's going to vary depending on individual users' use cases. Like I said, I really would like to get a database backend for the data store. And yeah, and that's it. Let me come back up here to, nope. This slide so you can see the link to the GitHub where it's at. There's actually 2 branches on there. The API server stuff is on like an HTTP API dev branch. I'm not set on how that's actually going to look yet, so I haven't merged it to master yet, but it's so far working to some extent. All right, and that's all I got. Any other questions? Apparently I answered everything as we went along.
Long ago, I looked into, I got one of those like FIDO keys,
Mhm.
looking into storing my SSH key on that and using GPG and all that kind of stuff. And as you've been going along here, I've been thinking about, I think it was called the Monkey Sphere. You ever heard of
That name sounds familiar.
Yeah, well, you don't know. I was just going to ask it. How would
All right.
all of this sort of tie into?
So-
Monkey Sphere uses like the GPG functionality to do the web of trust in terms of how you can authenticate with SSH, etc. And so I wasn't sure if you had any insight on.
So the question was if I'd looked into Monkey Sphere and my thoughts about how it ties in or correlates with this. I haven't, so I can't say. I know the GPG agent has the ability to act as an SSH agent, so you can store keys in it, etc. But I've never done any work on actually using a GPG Web of Trust for the authentication side of things. So, any other questions? All right then. Well, thanks for showing up and listening.